Hello everyone, welcome to my YouTube channel. This is the continuation of decision tree sessions, and if you are following my channel, in the last session we discussed about pre-pruning, post-pruning, and this session will focus on the pre-pruning. What does pre-pruning mean? Basically, using all the hyperparameters, select the best parameter and best score. So I let me just minimize my screen so that you can check the code properly. Okay, so if you are really following my channels, or by chance I will give the links of all the decision tree um, modules, whatever I covered. I'm using one inbuilt datasets, which is load best answer datasets, and basically using this few steps, I'm just converting that data into a data frame, because in the sklearn package it's kind of in the dictionary format, the key and value pair, but I'm just converting it into a pandas data frame. So this 5 lines, I'll give this complete code, you have access, so no problem. But after this 5 line you will have this code which is telling me that I have around 30 features and one target column. Again, this pre-pruning session, we are focusing on the classification problem. The next session, actually my goal is to explain the regression problem using the decision tree, and then show the practical on the regression using the decision tree. So high level, we have around 569 data, observations. We are splitting the data into independent features and dependent features. Then I'm splitting the data into training set and test set. So my training set has around 426 observations. Up to this, if you are following my classes, exact, no change. And I prefer to keep the same data sets for at least for logistic regression kind of a problem, so that we don't need to spend much time on this data preparation. Right now, anyway, we are not focusing much on the exploratory data analysis or feature engineering, which I will cover in my upcoming videos. But I'm using this ready data set so that we don't need to think about the ED or feature engineering. Okay. So first thing first is basically bringing the decision tree classifier from sklearn, and I am not at all using any things, just I bring the default classifier. Again, always remember Shift tab on a Jupyter notebook. If you do, you will get a lot of details, like what are the different hyperparameters are there, what are their default values. And in my last class where we discussed about the post pruning, we mentioned, like, if you just use the default, then what will happen? It will use this none. That means your tree will grow till almost in depth for all the nodes. So this parameter is a very crucial parameter for hyperparameter point of view. There are a lot of other parameters which my plan is to go through in another session. Otherwise, this video will be too long. But main intention is basically all these things are kind of hyperparameter, and we can pass different values, and using the GridSearchCV, we can find out the best uh, parameter for our model or for our data. Okay, so again, for hyperparameter, you need to create this kind of a key value pair kind of a thing, where I'm mentioning different options. Look, I mentioned both, and in my class I already mentioned these two things, Gini and entropy. Gini where the calculation is only kind of a summation based. So basically, because we are working on binary classification, so in this case, Gini will be basically the probability of yes square, probability of no square, something like this. Entropy will be logarithmic calculation, but we want to check which will give me the best. Okay. Splitter, again, best and random. All these features you can just read a little bit from the documentations. Otherwise, in the next sessions, I will explain all these parameters and what they are doing. So basically, after this, I'm just pulling the GridSearchCV and making a GridSearchCV object. So this one is object, and again, I am focusing right now on the accuracy. When I'm doing the GridSearchCV, at the same time, I'm doing cross-validation. This is, I always do this way because this is kind of a best practice. Like when you do the GridSearchCV, at the same time, do the cross-validation. Right now, I'm keeping it very simple, the cross-validation equal to 5. There are a lot of other different kinds of cross-validation. Stratified cross-validations are available for imbalanced data sets. And I will go through those kind of things also, like different kinds of cross-validation. But right now, our main intention is to show how this GridSearchCV is working and it's selecting the best parameter for the decision tree. Then what we are doing, we are just performing the hyperparameter tuning on the classifier. Now, once you run it, it will run basically fitting 5 folds for each of 132 candidates, total 660 fits. So look, this times it ran 620 fits, and out of that it will select the best parameter and the best model for us. I hope in last sessions I already mentioned like how this 132 is getting calculated. It's getting calculated from these parameters, and then each of this run it will do the 5-fold. So that's mean 132 into 5 will give you 660. Okay, and I'll show you in detail. So here basically it's calculating which criteria, which max index, and all those things. And finally, once it is done, then if you run this best param, it will give you the best param. And look, in this case, it's selected entropy, which is interesting. Though it is a logarithmic calculation, but still entropy, we found that the best criteria to find the impurity or purity of a split. So that's the power of a GridSearchCV. That though we know that Gini is kind of a simple in computation method, but entropy is giving me the better result. We found the max depth equal to 6 is giving me the best result. And max features is log 2, splitter is best. Remember one thing here, when GridSearchCV is giving you the best parameter, it is giving the best parameter, keeping this in mind that it should be low bias, low variance. That means when you're doing the training, you should get some kind of accuracy, and when you do the testing, it should be similar. It should not be that, okay, when you are doing the training, you get a huge accuracy, but when you're doing the testing on unseen data or something like that, then you are not getting the similar accuracy. So that's a very important aspect of this testing. Okay. So what we found that, okay, my best score is coming 94. Remember this number. So this is 0.94, and very, very important to remember it because I'll show you why. So what is my expectations? My expectation is when I did my training, I found this number, that's 0.94. So that means when I do the testing, I want the number to be something similar. Then only I can say that I have a low bias and low variance. Low bias means at the time of training, I am not overfitting. Low variance means at the time of testing also, I'm getting the exact similar kind of results. Testing error is also same like a training error or training accuracy. Clear? I think it's very clear. This piece of code is again actually giving those 126, how many we saw actually, how many 132 run, and here is basically again I'm explaining that 132 runs it's showing, and each run, if you just probably see here, each run has a 5 split. Each run has a 5 split. One, two, I think, yeah. 1, 2, 3, sorry, 0, 1, 2, 3, 4, 5. Each split. What does it mean actually? Just a high level. When we are doing a CV equal to 5, that means suppose you have 500 observations, just randomly 500 observations. What CV equal to 5 will do, it will divide that into 5 parts, and for internally, when it will do the first run, it will use the first 400 records as your training example, and 100 remaining record will be the evaluation records actually. Okay, and based on that, it will give you that result like, okay, what is my test score? So all these test score are based on that actually. So, sorry, here it's a mean test score. Mean test scores mean whatever test score I got from these 5 runs, and it's giving me that mean score. But understand the cross-validation part. It's very, very important from the machine learning point of view. It's absolutely important thing. Okay, and later I will tell you one more thing. Right now, whatever way we are doing the cross validation, that is good. But later I'll show you how to do the nested cross validation. Nested cross validation is very important, but you have to remember just one thing. When you do the nested cross validation, your execution time will increase lot. So very carefully you have to do it. But hey, don't worry, I'll show you how to do the nested cross validation and when probably it's the right thing to do. Okay. Um, okay, so I think our training part is done and we found, okay, this is my score. This is my accuracy score. Now I'm using my test data, which I already split it at the very beginning because I kept test data split here. Okay. And now I will use that test data on that model, whatever model I build actually. The grid search model, whatever the model I build, I will use that predict function. I'll bring this, I'll calculate the accuracy and the classification score. And what I found, that accuracy score is 0.944. Look at this, 0.944, which is exactly kind of on the same range. So this is a very good sign that our model, first of all, worked very decently. Like 0.94 is not a bad number. So it's a decent model and it is not overfitting or it's not underfitting. It's giving me the low bias, low variance result. So we should be happy. That's the very important thing when we are doing work with the decision tree. Right now, everything is related to logistic regression. Nothing changed when you're doing the hyperparameter tuning, when you do for regression. Internally, how regression works in next video, I'll explain that. But overall, this is the approach we should follow, this pre-pruning approach for any kind of data sets. This is the right approach when you actually work in the real life problem and real implementation. Hope you like this. Just give me a thumbs up or subscribe my channel. And again, I'm repeating these things. I'm learning. My main intention is to grow together. So if you stuck anywhere, email me, contact with me. I'll try to help as much as possible. Um, my philosophy is the more I share the knowledge, it's kind of a practice for myself. And plus, at the same time, if you can learn something from this, if it can benefit something to you, help the community, that will be great. Anyway, thank you. Have a nice day. Have a blessed day. See you in the next video. Thank you so much. Bye.